Hi, I'm Dr. A.J. Kumar. We're back here working on this. Just checking this. Working on Revelations 23. And what I want to do is figure out how to get get it to say chapter instead of book, or get it to say book or act instead of book. That's what I mean. Let's try renew command, book name act. Let's try that. Does that work? Oh, that works. Act 1. Okay, and then there's a couple of additional videos. Instead of just, yes, the one I'm recording, it'll be... begin, enumerate, let's just do this. Okay, item, anal 2, QAnal 3, abstract, algebra 21, 21 especially. And I wanted to split up the prereqs into really prereqs. Okay, and then begin description. And description. Item need would help. Important would help. Okay. Item essential would be high school math. Important would be prior exposure to calculus. Prior exposure would help. Group theory, combinatorics, probability, abstract algebra, topics, QAnal, calculus, group theory, combinatorics, probability, statistics. What else are we going to be talking about? Let me look at my outline. Polynumbers, physics, electromagnetism, QAnal, Pascal array, symmetries, tons of topics. Topology, analysis, of course. QAnal 2, QAnal 3. Okay, I'm going to close this. What's on 4? Okay, it finished encoding everything. F cat dash safe 0 dash I. mylist.txt dash c copy QAnal 003.mp4. Let's try this. Rumble. Here, let's just look at my channel. Some of these have rate 8 views and 47 rumbles anyway. Upload video. I want to see how long it is. 2:30, okay. Evaluations 23, QAnal 3. More in my work vlogs, which I think I will maybe make into their own playlist, work vlogs. QAnal. I don't care anymore. Okay, choose my own. Where is it? Here we go. Dr. H.A. Kumar. Calculus, math. Trying the exercise ball and see if that helps with my back, because you know, I couldn't work for more than like 10 minutes at a time without just horrible spasms. Okay, and then we also want to go to YouTube. Just go back. Documents. And this will be in the QAnal playlist. I like this sort of thumbnail to sort of briefly outline the chapter. The act, okay. Question I have. How big of a file? 500 megabytes? Okay. Whoa. It's 2.5 hours. Okay. Need to be doing more work than that, but the thing with my back was just an absolute killer. But anyway, let's keep going. Okay. Goes with videos. Oh, I wanted to see if this worked. Yeah, okay. Prereqs, essential. Okay. Let's try that. Does that fix it? Can't remember. There's a way to get it to not have space before and after. Oh, I might have a macro for that. QAnal. Alright, we're already 16 pages. Okay. Contents. Combinatorics, polynumbers, preanal, calculus for white people. I like that. Let's just read this again. Group theory, combinatorics, we're taking this, okay. Let me read from the start. Post-revelation thinking is never the same, and you can't make people have revelations. You can just lead them up to the point they are likely to have one. This revelation aims to explain why the derivative of x to the n is nx to the n minus 1, and to put this fact in a proper, formal mathematical framework. Examples for cases n equals 1, 2, 3 are shown in the following images, figs 1.2 to 1.4. The derivative in each case is the coefficient attached to delta. The basic logic is exactly the same as with complex numbers. With complex numbers, we take the normal rational numbers, fractions, and add in a fake number called I, which has the property that I squared is equal to minus 1. In preanal, we are adding a fake number called delta, which has the property that delta squared is equal to 0. The logic of taking the derivative is roughly analogous to finding the imaginary component y of a number x plus iy. As we will see, preanal is a bit more involved and deeper than simply delta squared equals 0, but that's the basic motivating idea. We can also consider systems where delta is not equal to 0 and delta squared is not equal to 0, but maybe delta cubed is equal to 0. The highest exponent k of delta where delta to the k is not equal to 0 is called the order of precision. So in our case, where we say delta is not equal to 0, but delta squared is equal to 0, the order of precision is 1. As we will see in preanal, the, quote, order of precision, unquote, idea will replace the CIA concept of margin of error. The arc of our story. Here's the rough trip plan again. Group theory goes to combinatorics, goes to polynumber. Not again. I made a mistake. Here's the rough trip plan. Group theory to combinatorics to polynumbers to calculus with polynumbers. We're taking the scenic route, not shipping straight to the end. We're going to pull over and sightsee when there's a shiny object. This is meant for someone who is more or less a noob in mathematics and wants to see an interesting story. We're going to survey a lot of stuff that is, quote, mathematical common knowledge, unquote, if that makes sense. By C-tier analogy, pretty much everyone in the computing world has at least a passing familiarity with, say, regular expressions, shell scripts, and basic HTML. Pretty much everyone in mathematics has a passing familiarity with group theory, combinatorics, probability, electromagnetism, and linear algebra. We're exploring the map, seeing the way the landscape works, how the map ties into itself, trying to build a model in our head to see the big picture. We're not doing the shortest path to get from point A to point B. I am assuming you are reading this because you're interested in learning about math, not because you are in a hurry. Here's the rough trip plan again. Group theory to combinatorics to polynumbers to calculus with polynumbers. And I want to read this book that I have. And I also, where is my Baby Rudin? Baby Rudin. Do I have it here? It doesn't look like it. The PDF. Documents. It's Rudin, baby. Okay, and I want to go... I want to go read chapter 10 of this, which, let's go to 245. It won't quite be there yet. Okay. I want to reread this. Okay. This isn't a proper reading. This is me kind of scanning this. Okay. Integration can be studied on many levels. In Chapter 6, the theory was developed for reasonably well-behaved functions on subintervals of the real line. In Chapter 11, we shall encounter a very highly developed theory of integration that can be applied to much larger classes of functions whose domain are more or less arbitrary sets, not necessarily subsets of Rn. The present chapter is devoted... Okay. So this is like a rectangle or something like that. There's got to be a way to simplify this. That's what I'm thinking. This is the Stokes. This is the fundamental theorem of math that I always say is, it's this theorem right here, Stokes' theorem. And I'm just trying to like remember the. I went through this years and years ago, and I just don't remember it. I mean, I kind of remember it rings a bell, and I just don't remember this well enough. Closed forms. Vector analysis in R3. How does algebraic calculus work? Right here I have an algebraic calculus book. Let's go. let me look at Wildberger's algebraic calculus. Okay, let's just skip ahead to I might put headphones in because I don't want to get copyrighted, but what did I really want? The Bezier curves is important, I think. How many videos are there? 56. Yeah, let's look at the fundamental theorem of calculus. Okay.
In this lecture, we're going to take out some of our photos and come back to solve others and also to so basically, in this kind of series, SKN equals 1 to the k, so 2 to the k, plus all the way up to n to the k. The summation notation, sum I is 1 to n, I to the k. And the following here, the k, are like 0, 1, 2, 3, 7. And we're going to be trying to establish or find a formula for the k powers, right, from 1 up to r. Now, we know, so classically, that there are these wonderful formulas for k equals 1, 2, 3. So the sum of simply the natural numbers themselves from 1 to n.
I feel like I gotta read.
It's
just this. I'm stealing most of this from Wildberger. Okay, I think you know what I gotta do is 56. Okay, let me do 3 videos. Can I do 3 videos a day?
So
Okay. Okay, no signed area. Let's go back and watch this. I might need to take notes. So I've talked about this signed area of an oriented triangle in the abstract algebra playlist. Okay, fuck off. Yeah, okay, so I talked about this and explained why this was true, I think in even more detail than Wildberger did. And I also went and generalized it and showed that, well, I gave a couple of examples at least where I was like, hey, at least in my experiments, I'm not sure why, but this, you can reason through pretty simply, you know, why this works for, I should probably be paying more attention, but you can reason through why this works for triangles, just visually by partitioning up a parallelogram. And I did a video somewhere in my abstract algebra playlist. So anyway, Alright, so the cross product. Here, maybe let me go back and turn up the volume.
And remind you that proportion A to B and another proportion C to B, then they are equal precisely when AB minus BC equals 0.
Oh, let me turn on the subtitles. There, that's better.
It's telling us that if you think about the vectors heading from the origin to the point A.
And then I can just, here, maybe open the transcript. Then I can just follow along. 323. Of course, he overloads the terminology. That's wonderful. Okay. I think we do need to go through the exterior algebra and like do that properly. Alright, I'm making this way too complicated. So it's bilinear, that's what he's showing. So this is, I think, the idea that all of the forms are determinants. So he's defining a form. In modern math speak, he's talking about a form. Okay. What is Meister's formula? Let's just look at his slides. Let's go back to, let's try looking at... I think, yeah, he's making it too complicated, but I think my presentation was a bit simpler than this, but I stole my idea from him, or I learned it from him, so yeah, okay. Slide 3. Let's do slide 5. See if we can get to slide 5. Oh, still using this slide. Its signed area is
here is a point E cross BA, or what happened? CA cross CB.
Phoebe. I was wondering what Phoebe was going to be. It's CB. Where's Meister's formula? Okay. Yeah, signed area of a side, that's what I was doing. That was saying that, yeah, you have to kind of... Okay. Yeah, okay, yeah, I've done this. I've given this presentation 50 times. I'll try to remember to link these videos below. Yeah, you can talk about oriented polygons. Yeah, he's just going more slowly. Okay. Yeah, I get this. Meister's formula. Right, okay. I don't know why that needs to be named after someone. It's kind of an obvious idea. Or it's obvious if you understand the logic. That's kind of silly to name it after someone. I guess all great ideas are obvious once you understand them. Yep, I get it. Okay. Let's try the next one. Okay. As funny as I can hear this in his voice, despite I don't think I've ever watched this video. Okay. Ah, okay, so he's doing... Ah, okay, I see what he's doing. He's picking some specific curves. Okay. He's showing how to compute signed areas. Okay. Okay. I'm just going to try to like go through this playlist and see the general structure of his arguments. This is the one thing that's I find the videos way more effective than reading, but sometimes when I'm just trying to like quickly find some information, the video is really tedious. That's also why I do the revelations, is so that I can kind of have a written record. A lot of my revelations are just Wildberger's videos in PDF form, let's be honest. I love this guy. You know, I thought I was I thought I sucked at math because I was like getting into this higher level stuff and it just didn't make any sense. And I started watching this guy's channel, and he had the same opinion. It doesn't make any sense because, you know, the logic just gets really gummed up and it just becomes so clunky and it loses all of its elegance. And it's a result of poor abstraction. So you get, what do we call them, angry dragon problems or waterbed problems or technical debt. The word is joggerlicious. Is that when you write something joggerlicious, okay. Probably there's some important detail. Wildberger does these things where he hides really important ideas and like it's kind of a mathematical thing where you just kind of show something that's simple and it's like what the hell does this have to do? Right, it's like I should show you, you know, a ball on a string and I'm like, who gives a shit about a ball on a string? But then that actually has a lot of really cool important stuff. And you kind of can't see it. Okay, so data structures and polygonal. Why does it keep closing the transcript? I want to read the transcript. Okay, we're going to introduce political splines. Okay. Oh my God, this notation is garbage. All right. Notation as semantics is cancer. Yeah, okay. One reason now as a programmer that I like Wildberger is because, like, if I need to go program something, right, it doesn't matter what it is, I will go specifically find Norman Wildberger talking about it because he will phrase it in such a way that I can easily translate it into code. His notation sometimes is like, what the fuck, but I can always, if I spend the time to decipher it, figure out how to translate it into code. Most math, you literally cannot translate into code, and Wildberger goes to a lot of effort, and I really appreciate that, to make sure that I can put it into a computer. And so if I need to put it into a computer, I go find Wildberger talking about it. Alright, anyway. Yeah, you've talked about this 50 times, I get it. Yeah, then it's signed, yeah, okay, yeah. Okay, let's go to the next video. Parabolic splines and Archimedes. Okay. Transcript. I'm Norman Wood. Okay, today's video. Apollonius, I want to read his stuff. You know what I might do with the reading playlist is not do like the really deep dives. Might just read it the way like I read it. Like you see how I'm reading this, I'm just skimming. And I'm just... Right. Oh. So yeah, okay, that's what he's talking about. Okay. This revelation, by the way, I'm basically... My idea for QAnal is basically the same as Wildberger's algebraic calculus. Okay. Consider the OR. What? Huh. I'll have to go back and look at this again. I gotta go back and read from the beginning. I was like 4 minutes in and I got, okay. His differential geometry playlist is also going to factor into this revelation. Okay. Oh, I should put Wildberger's algebraic calculus. Okay. Wow, it's still submitting? Let's just go QAnal 2 through 4. Well, there's going to be more than... Okay, QAnal 2 through... I don't know how long this will take me. Let's put a question mark. Item Wildberger algebraic calculus. Wildberger map foundations, and then NK, Wildberger differential geometry, okay, and I'm at that annoying moment where it's like I need more information for all the stuff to cancel in my head. I can feel I'm right on the edge of a breakthrough. I don't feel like I get algebraic calculus. And I'm not devoting enough time to it, I think. Okay, anyway, let's go back and read this transcript. We're at 320. Okay. Right. Right, signed area, got this. Oh, okay, so those are integers, okay. Oh! That's cool, I'm gonna screenshot that. I see. That's really interesting. I gotta go back and watch the other video, because now I think I missed some important stuff. That's interesting. What the fuck? Wow. The area of that oriented polygonal spline. The fuck is K choose to who? Let me get your fucking hand out of the way, Wildberger. There we go. That's equal to k minus 1 times k over 2, which is k choose 2. Okay. Oh. Oh, but it's the sum. Oh. There's a lot more. Yeah, okay. So, I have a phrase which I think captures Wildberger's essence. Wow, I didn't know he was Italian. Look at this. Anyway, I have a phrase, God doesn't give a shit about geometry. And I think that's really Wildberger's idea as well. God doesn't give a fuck about geometry. Anyway, I like this Italian pose that he has. Anyway, this by the way, the sitting thing is much better for my back than standing. I gotta check something. I just got an email. I gotta look at something. Alright, I'm gonna pause, stop this video, and go check that out. Okay, bye. Alright, that turned out to be nothing, so let me go back and let me just 22. Nope, that's the current one. 2137. Copy. Let me just open with MPV real quick. Okay. Copy paths. CD documents, make dir QAnal 4. XV, FF-I, PTO1.mp4. Okay. So, I do that recoding thing. Oh, let me open up Firefox. Go away, OBS. Okay. Where is my transcript? Where are we? We're like 7 minutes in. Okay. So it's the sum of 0, 1 choose 2. Yeah, because this segment is going to have 0, 0, 0. Right. Up to sign of AN. Yes. That's interesting. Yeah, okay. Okay. The pyramid. The pyramidal node. Okay. Okay, so I think I'm going to have to spend a fair amount of time talking about the Pascal Triangle. I think that'll be useful in the combinatorics section. Okay, because I want to talk about this result, because this is cool. How we doing? Okay, so that was an hour work. Okay, that's cool. But, okay, I gotta do Duolingo before midnight, so... Alright, I'm in the demotion. Let me get out of the demotion zone. Boy, okay. Okay, I'm just... You know, okay, let me see. I haven't practiced in a while, and so I'm having trouble reassembling. Okay. Let's do this. school. That's like... No, it's gakko.
Gakko.
Yep.
Tempura.
Okay, there's two translations, pencil or tempura. I have no idea what the fuck a tempura is, but I'm just gonna guess that. Fermented soybean. How the fuck am I supposed to know?
Natto.
Natto.
Gakko.
Gakko, that's school. Pencil. Is it like pensiru or something? Some stupid shit like that.
Enpitsu.
That sounds like pencil. Yeah, of course.
Ocha.
That's tea. I'm just doing the easy one so that my streak doesn't get broken. A ticket, that's like, boleto. No, wait, no, that's Spanish. So, kipu does sound right. Let's look at the other ones. Gakko? No, that's school. Natto, that's like the soybeans. And then, hiragana. No, that's hiragana.
Hiragana.
Yeah, that.
Hiragana.
So it must be this one.
Kippu.
Kippu, that sounds right. That's like boleto. Right.
Kyou.
Kyo, that must mean today. Hiragana.
Hi. Da. Ga. Na. Natto.
That's fermented soybeans. How the fuck would I ever know that? But
Tempura. Enpitsu. Enpitsu.
today, that's kyo.
Kyou.
Oh wait, there's one. That's Q.
Kyou.
No.
Kyou.
I want kyo, and then what's the other one? Ochaya? Ocha.
Ocha. Ocha.
No, it's Q. It's kyo. It's kyo.
Kyou. Kyou.
Kyo.
Hiragana.
Hiragana. Okay.
Hi.
Ga.
Na.
No. 9. Oh boy. I think that's Q.
Kyou.
Let's try. Yep.
Kippu.
Kipu. Yeah, okay.
Kippu.
Green tea, that's Ocha.
Ocha. Kyou.
Q.
Kyou.
There we go. A school, that's like gakusei or gakko or something like that. Here we are.
Gakko.
Fermented soy. Oh, that's the natto.
Gakko.
Nope.
Gakko. Natto.
There we are. I saw the weird little sideways backwards C and overmatched. Alright. Alright. Cool. Am I out of the demotion zone? No. Alright, let me... See, there's a bunch of them that I have gold on, but... Okay. Let's do... My katakana sucks as well, so let me do hard practice on katakana. Camera. Very inventive Japan. Very inventive Japan. Europa. Spain. What is that one? Philippine. Okay, that nope. Okopi? Yokopi? What is that? Europa. Okay. That's I'm guessing that's Europe. Yep. Philippines. Africa.
Roma. Asia. Australia.
Philippines.
Asia.
Asia. Australia. Yeah.
オーストラリア、ロシア、
エリカ、
アフリカ、
アメリカ、カメラ、
ヨーロッパ、
ローマ。
ローマ、エリカ、ロシア。
Shit, now I'm one behind the demotion. Okay, let me try something. Cause I'm bad at reading that weird script. Okay, let me try. You know what? I don't give a shit. Okay, let's get back to math. Math is way seriously. I have a much easier time with math than I do with Duolingo. It's just because math makes sense. So I'm looking at my Galton board. Where are the pyramidal numbers? So the triangular numbers you can get by reading off what would it be, the third column of the Pascal array. Will the fourth column of the Pascal array be the pyramidal numbers? Okay. Okay, what do you mean possibly define? Okay, 1457, okay. See, the important idea with this, the reason that the algebraic approach is so much better, is that all it relies on is the fact that you can have well-defined algebraic operations. It doesn't rely at all on the geometry. It doesn't rely on limits. Limits is a very geometric idea. Okay. That should be the first. Why the limit concept is joggerlicious. That should be a chapter in Calculus for White People. Okay. Okay. You know what I need to do? Let me zoom in. Okay. Chapters. Touch B2 combinatorics. Okay. Touch B3 polynumbers. Okay. Touch B4 QAnal. Okay. And then XV. Okay. Yes. Chapter. Why limits are joggerlicious. Okay. Should I use the J word or just go full N word? I want to put this on YouTube, so I won't. I like Joggerlicious better. And then we get Jogger script. The CIA's why CIA limits are Joggerlicious. Okay, that's what we'll put. Okay, and then so I'm starting to get scope creep, and I want to keep this pretty minimal, and we're just gonna do a shallow basics of preanal. I don't want to get too fancy, but I do want to give some indication of what's going on. I think I won't talk about anything beyond Taylor polynomials. But the idea, because I'm wondering, can you take the polygon spline idea and talk about like so instead of line segments, oh, is that what a Bezier curve is? God damn it, is that what the Bezier curve algorithm is? Did I just think of the Bezier algorithm? How does this work? Bezier surfaces. Okay. Okay, specific cases. Yeah, okay. Okay. I think I just, in my head, figured out Bezier curves. Because I just had an idea, and it looks exactly like this idea. Except this guy already figured it out in the 60s. Yeah, okay. Okay. Bezier curve. I wonder if there's something like that we can do that's like Fourier analysis for Bezier curves. Because this Bezier curve idea, it looks completely algebraic, which probably means it works over a finite field. Okay. Right. You know what it is? It's probably the theorem Okay. So, 2 points determine a line. 3 points determine a conic. Yeah, okay. 3 points, so we want a conic that goes through 3 point. If you pick 3 points, there's probably a unique conic that, or maybe it's a unique parabola. Maybe you need 4 points. It might be n factorial. 3 points would definitely give you a parabola. You could definitely get a parabola. I gotta go read about this or watch Wildberger's things about the Bezier algorithm. Okay. Because I bet you can compute the integral enclosed by a Bezier curve exactly. I bet you can compute that exactly. Okay. Certainly with jogger calculus you can. And I wonder if with algebra you can. Okay, we're not going to get into Bezier curve. You know what? This is great. This is important, but I don't need this for what I'm doing. Okay? I don't even know why I started reading about all this stuff. Okay. Okay. Giving this presentation without group theory would be like making pornography that doesn't have a plot line. Okay, specifically, okay. Let's work on the thing with group theory. Okay? And this will be more on the Math Foundation series. I don't want to bring in some fancy algebraic calculus. Alright. But the Bezier idea is basically preanal, isn't it? It looks like it. I gotta look at the details and figure out how that works. But that's interesting. Okay. So chapter, we're gonna start. So I did a walk earlier, and I recorded a bunch of stuff, and I don't know, a voice recording. So maybe I'll play that. Maybe I will put that in the video. Fuck off. It's asking me to rate his app. Fuck you. Okay. Let's do equivalence relations. Okay, oh, Craig has a great quote about how that's an incorrect quote, that programmers think, or that mathematicians think objects are groups, which, no, that would never cross a mathematician's mind. I don't think he knows what a group is. Which makes me question a lot of his other thinking, because that concept doesn't even make sense. Anyway, the chair is a godsend, I have to say. I'm also getting kind of hungry. Okay, I'm gonna make myself wait for an hour. How about that? I'll wait until midnight to eat. I will probably go get some water or maybe some tea. He knows what a relation is, doesn't he? So a relation means a function R. Okay. Everything is equal to itself. Everything, two things that are equal are equal. Equals B, then B equals A. if A equals B and B equals C, then A equals C. Okay. And I want to draw a diagram here. Okay? And because I want to mix in diagrams and I can't put it, okay, let me, this is great, this is great, but not what I need right now. Close the tabs. I'm very hungry, suddenly. Okay, okay. Let's call these symmetries. Okay. Groups. Yeah, okay. Oh, I should make a fake block quote for this. 90% of the difference between any two fields of mathematics is in their definition of equals. And in a deeper sense, all of mathematics, most of mathematics, is just changing the definition of equals and seeing what happens. Most of mathematics is just changing the definition of equals and seeing what happens. What exactly, and then we can just go, what exactly? Okay, I need a block quote template for myself. I have one for Craig. Oh, I have a great idea. Where is his retarded quote here? Let me find it in that. I have a great idea. Convo Everett. Here we are. Here we are. I've got it. Okay. I've got it. Okay. Open. Okay, we want to go to Rev 23, include images. Okay, we'll take his Polish soup quote. Okay. Okay. Ah, shit, how do I set this up? Okay. Okay. T, text tool. Lazy eval. Okay. Edit. Okay. Copy. Let's try this. Paste. So the idea I have, and now I can't quite figure out how to make it work, is I want to take one of these stupid physics quotes of his and put it and have it be like Craig Cannon on why you shouldn't use weed, you shouldn't smoke weed. Now I'm not sure how to do it. Or just Craig Cannon on marijuana. Okay, and that would be. Okay, yeah. Because I always have his quotes be Craig Cannon on topic X, but in this it'll be Craig Cannon on Craig Cannon on cannabis. Craig Cannabis. Craig Cannabis? Could that be his name? And then we make him green? Could we do that? Yeah, okay. His stoner personality is Craig Cannabis. I like this. Okay, 150. Let's try that. 20, 30, 25, 28, 29, 28. 128 it is. Okay, and this is Craig Cannabis. Okay, how do I switch this from red? Oh boy. Apply layer. How to switch? How to? Wait, let me just try layer. Colors invert. Let's try. Nope. Let me try GIMP switch red to green. So I want to make him green, and that'll be Craig Cannabis. Whenever he says something stupid, I'm going to attribute it to Craig Cannabis. How about that? I mean, look at that. I'm sure that this makes sense to him, but I just listen to that and I'm just like, what the fuck are you talking about, man? All right, Craig Cannabis. Okay, GIMP switch. Okay, and that'll be our. Okay, and then what's the context where I put this in? That's I think equally important. Get switch red to green. Okay, let's try. Let's first save. Okay, filters, colors. Uh-oh. Colors, map, color exchange, two color, want to go with like a green. Let's look at that. No. No. I wonder if there's the original thing. Okay, colors. Let's do levels. Okay, so because I'd like to make him green instead of red. Colors. Let's try curves. Green. Red. How do I, okay, I know the thing I want, which is I want the swap channels. How do I do that? Yeah, swapping red and blue channels. Let's try this. Wow, this is a 2008 video.
First go to the Colors tab, and you want to select Levels, and then click the Auto button. It should change the image so the trees and grass are white and the sky is black and dark orange. Now you want to click the Color tab again. Go down to Components and off from the
channel mixer. Oh wait, let's try him as black and white. Oh, that works as well. Oh. As black and white. Great canvas. Okay, let's try.
Their clip channel mixer. It takes a while to open due to their large picture and the recording software. Now it's open. You need to select red in the output channel and then change the red percent to 0 and the blue percent to 100. Now select blue in the output channel, then change the red to 100% and the blue to 0%. That is your final image displayed there. Click OK and you have now swapped over the red and blue channel.
This is fake news. Okay. Here, you know what I'm going to do? And it's just going to do alpha to selection. I'm going to do the same way I do the glowing thing, where I make a new layer, transparency. Okay, and what I'm going to do is I'm going to pick like this green color. Okay, and then select. Fill with foreground color, and let's see if I and then dissolve, lighten only, overlay, soft light. Can we do that? Yeah, I like Craig Cannabis. This soft light thing would be good for the glowing thing as well. Mode. What is subtract? No. Gain. Gain merge. Hue. No. Difference. Hard light. No, we want soft light. Craig Cannabis. I like this. Alright. Let's save. There we go. Craig Cannabis. All right. All right. This is what I spend. I spend a ridiculous amount of my time orchestrating like trolls that won't come about for like years. I mean, there's you'll probably never actually look at this document, but it's still worth it on the off chance he does. All right, that'll be in the. Okay, you know what I'm going to do? Now I have to do application to physics. Okay, application. Okay, application. Physics. Physics application. Okay, solving circuits. Okay, and then body.tech. Okay, we're just gonna copy this. Begin figure, and it will be What was it about? It was lazy eval, that's right. Craig Cannabis tells us about physics. I'm going to call it Craig Cannabis. That light might be too harsh, but we'll deal with it. And where is our PDF? Okay. Physics application, solving circuits. Craig Cannabis. Jesus. This is great. This is great. Should I put like the weed symbol on his forehead? Or maybe like translate smoke weed every day into Japanese and put that shitty tattoo on him. Let me try this in Japanese. Smoke weed every day. That's the name of a song, I think.
マリファナを毎日吸う。マリファナを毎日吸う。マリファナを毎日吸う。
That might be too long. Fucking katakana. Smoke weed every day. How about legalize it?
それを合法化する。
Maybe put it in Chinese, and then he can still read Chinese.
合法化。每天抽大麻。
Okay, let me copy this, put it in Japanese.
Stoner cannabis.
Jesus Christ. Alright, no, let's try, legalize it.
合法化。
Okay. And then Japanese. Sometimes you can just type the check. Legalization. Okay. That's a shitty tattoo. That's a great tattoo. That's great. That's great. I'm gonna put that. That's his tattoo. I love that. Okay. I'm gonna put that on his forehead. Okay. There we go. It's gonna be a text layer, and let's just put it here, and we'll make it black. Okay. And let's make it like 50. Let's try that. Is that a good size? Where's a better place to put it? Is his face? That's too obvious. His chest, would that be good? I think his chest, or maybe his stomach. Oh, the inside of his leg. Can we do that? Ah, it cut off. Let's see. Maybe here. I liked the face tattoo idea, but let's see. The inside of his leg. Maybe here. I like if it would go like down. Oh, and his neck maybe? Could that work? Because we've already got this tattoo right here. Let's see. I should make the Craig Cannabis thing the thumbnail for the video. That could work. I shouldn't make fun of him. I should. I mean, the thing. Okay, you know, the thing though is that our friendship is predicated on not dunking on each other when one of us does something stupid. That's a thing. I don't know. This is pretty funny though. I think if it's funny, that overrules. I'm sure. I mean, I actually haven't. Let me try to see if I can make sense of this. I mean, I understand his idea. I think he's just trying to project his computing ideas. Okay, I want to make it. I think I want to go with another chest tattoo that goes like down this way. Okay, so let's put it like this. And should I make it back? Should we? I think like it'd be funny if one of them was backwards, but that probably changes the meaning. Yeah. Oh, it'd be funny if it was like Korean instead. Okay. And let's make it bigger, 80. Yeah. Okay. Okay. And then is that the right side? That's fucking huge. Yeah, that's the right like hugeness. Okay. Now we're gonna rotate this. Rotate. Where's my rotator? Here we are. Nope. Okay. What? Okay. Might do more rotation later. Okay, I actually want to. What's the keyboard shortcut for Shift R? Okay. You know, this is valuable because I'm learning how to use GIMP. So, okay, and then opacity. Drag the opacity down. Ah, you know, we want to put it below. There we are. Yeah. It's actually funny that it doesn't match the other font. That's good. And then it just says legalization in Chinese, which is a different language than the Japanese. Or it says legalize it in Chinese. Okay, this is good. Okay, and then what we want to do is use this perspective tool. Which one? Here we are. I'm eventually going to go through the mathematics of how this tool works, but just get it so that it kind of matches the curvature of his skin. There we go. And then what we want to do is go through with the blur tool. Where is the blurring tool? It's one of these. Is it the smudge tool? Yeah, maybe let's try smudging. Does it only, it should only work on the layer, I hope. Yeah, okay, perfect. Okay. And we're going to want to make it smaller. And that's way too fast. Let's try this. Yeah, good. Just need to do some anti-aliasing, that's all. Here we are. And this rate needs to go way down. Let's try going to 25. Why can't I just click and fucking... There we go. There we go. This is perfect. Go. Just doing some anti-aliasing. That way it's the right amount of blurry. Because, you know, it's a JPEG, it'll be blurry. Okay, here we are. I want him to have to try to figure out what the hell this means. So the more I can obscure the character, the better. Here we are. Here we are. Let's go around. Here we are. I have to maybe zoom out because this might be too harsh. No, it's perfect. It's perfect. Okay. And we might want to tone it down a little bit even. This smudge tool is great. Because it's like aging it into his skin, right? Perfect. Okay. Yeah, you know what? That's perfect. I'm just going to leave that as it is. Yeah. Perfect. Okay. Let's kill this. Q. Kill that. Kill that. Okay. And let's try it again. See how visible the tattoo is. Legalization in Chinese. Eventually, he's just going to be like completely covered in shitty tattoos. That's great. I mean, I could make it a little bit better. I can think blurring it and maybe making it a little bit more transparent. But you know what? It's great, and I don't want to touch... It's at, like, a point where I could very easily fuck it up and not be able to unfuck it up. So I'm going to leave it as it is. Okay, perfect. Here we are. There we go. Greg Cannabis tells us about physics. Alright, I gotta focus. Alright. I would also like if the spacing was less, but you know what? I'll deal with it. I'll live with that. I like it. Alright. I should have put legalize it in English. That would have been better. I don't know. This works. I mean, just covering him with shitty Japanese tattoos until, like, he's just covered entirely. Alright, I gotta close the picture. I gotta keep laughing at it. Alright. Alright. Now I have to talk about the physics application. I was debating that because I was kind of... Anyway. Alright. Alright, I want to make a diagram for this. Okay. 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 Alright, so let me make one for homotopies. Alright, and then this can just be an aside. So, this will just be a formal definition of the homotopy. Who do I want to cite? J.P. May, that would be the best one. May's algebraic topology. Do I have that with me? No, I have Maunder. Let's try Maunder. Let's see if he has a good definition of homotopy. Wow, I have this ass huge bookmark. Maunder for homotopy. 25. Oh, there's such a thing as a based homotopy. That's great. Okay. 25. This is 35. That would explain why there's no definition. 25. Ah. He's talking about maps being continuous. I would like if two shapes were homotopic. Maybe I have to find a different book. Let's find Homotopy. Do I have Hatcher? Where is Hatcher? This book is good. I like it, but it's very. It's not what I'm looking for in terms of a definition. Oh, maybe. Oh, just looking what I have on my bookshelf here. Might have to go find another book. Ah, I have Hatcher. Let's look in Hatcher. Homotopy. H. 3 and 25. Let's try 3. Huh. Okay. So I like let's try 25, see what his definition is there. Go try 25. So typically, I guess, all of these have definitions of functions being homotopic. The homotopy is a generalization of the idea of a continuous path. That's what it is. Okay, I'm going to write a false let me just call it a fake definition of a homotopy. Okay. And I'll say, okay, fake definition of a homotopy. Let's just call it this, fake definition of a homotopy. It is the generalization of a continuous path. So I understand now why you think about it in terms of maps, because you think about the space being embedded and the embedding is a map. Okay. Okay, so here is our point. Let's draw this needs to be fixed. Fake definition of homotopy, generalization of a continuous path. A is and this space here is the plane. To B okay. Sure. Fake definition of homotopy. This is a fake definition of homotopy, but it's a generalization of a continuous path. Okay. fix two endpoints. And let's have and let's call this one delta. This is T. This is supposed to be blue, gamma. There we go. And this should be more clearly a T. That should be bigger. T. And then let me give an example of not homotopic. And how am I going to draw this? Let me draw circle. And God damn it. Y. There we go. Oh, let me save homotopies. Okay, and then what I'm going to do is I'm going to draw a point on the cylinder. Let's make it blue. It's telling me that I can go eat, but no. Okay, and then delta does not. Okay, and then I'm going to need to edit these with GIMP. I think the pictures are in a sense more important than the words. I think that maybe that should be my orientation, is picture oriented, right? Because people, nobody wants to read a wall of text, but people can look at diagrams. Okay, so I'm gonna do is create a new. That's fine. Advanced options, fill with foreground color. That's fine. Okay. And what I want to do is, I don't want intelligent edge. I just want like a polygon select. Is there a way to get that? Yeah, okay, here we are. To new layer. Okay, and I also want to take this from here, cut, paste as new layer, move to over here. That's fine. Then merge down. Okay, and then it's just bothering me that it's off center. Really? Why is it doing that fucking retarded? Did I select the wrong tool? That seems like more like my fault. Okay. I hate that edge. That edge fitting tool doesn't even work. There we go. To new layer. There we are. That's roughly centered. Crop with a ratio of 16 to 9. There we are. Good. Or that's good enough. Homotopy dim 0. I don't want it in my documents. Let's just call it there. That's fine. Okay. Now okay, and then let's get this. Gamma is homotopic to delta. We'll Control C. N. New with foreground color. To new layer. This is fine, just need to crop it. Right. Homotopy dim 1. And then this cylinder thing. C, Control N, advanced options, fill with foreground color. Paste, Control C, Shift C. Yeah. That's about right. Just, I don't like all this wasted space, but I will live with it. Example. Okay. Okay. And then, begin figure homotopy from 0. Idea in dimension 0. Homotopy 0. Then dimension 1, and then example. I think it's non-x, right? It's non-example. Okay, fake definition of homotopy. Then new, which is 80 by 720. Why is the dog chimping out at midnight? Um, 100. Let's just do fake definition. Bold, and let's make this yellow. Hey, I said make it yellow, you fucking... Yellow. Yeah, there we go. I like this sort of image-oriented style of revelation. I think this is going to be kind of an innovative revelation in the sense that this is a step up from the prior revelations, it seems. And you know what's funny is that the quality of my work seems to be increasing when I'm doing this, anyway, doing this narration thing. Okay, let's see. Homotopy. Oh boy, what did I call it? Fake definition homotopy. For a proper definition, see text site Hatcher P3. Okay, text site 3 Hatcher page 3. Homotopy fake defn. Note that homotopy, that homotopic term, homotopy equivalence, means something slightly stronger than term homotopy. I want to put this as part of the caption. All of them. Example of two-path this implies oh, I already have Hatcher in my citations. Great. Okay. Hatcher. Yep. Awesome. It's page 3. I already have him in my bibliography, apparently. I assumed that citation wouldn't work. There might be too many pictures now. Is there such a thing as too many pictures? I don't know. Oh. What I wanted to do is have the block quote template for myself. Alright, this, I kind of, how long have I been going? I kind of need a break. Okay, over 2 hours. So, I mean, I got some more, hour and 43 minutes, and then plus the other session. I don't know how long that took. MPV, how long was that? Okay, yeah, I've been going for going on 3 hours in this session, so I'm glad I got my back situation sorted out, but anyway. Okay, working more on Revelations 23. Git commit -m adding a lot of diagrams. I like the diagram-oriented Revelations, because if the closer it is to a picture book, the better. All right, and so what should my thumbnail be? Okay, maybe it should be one of the pictures that I've done. I don't want to give away this, because if Craig looks at my channel, he'll see this and it'll ruin the joke. Because I want to give him Revelations 23 and have him react to it. Meaning, and that still doesn't mean, okay. Oh, yeah, that's good. Working on Revelations 23. Okay, yeah. You know what I'm going to do? I'm going to take this quote, post-Revelations thinking, quote 8. Which one is it? Let's make the... Okay, open with GIMP. Where is GIMP? Okay. And then just add QAnal 2. It'll be QAnal. And then 200. No. Never mind. Here, you know what I'm going to open it with is my paint. Save as QAnal 4 thumb. Where's my pen? It's just... It's 23. Yep, let's just leave it at that. And kill. Let's just see what it looks like. I like the sort of hand-drawn thumbnails because that's sort of enforcing a consistent style. Oh, I got to turn off the recording before I go re-encode my content. Okay. All right, thank you.